Yes, so here we are doing the DC motor interface. Yes, so here we have taken the DC machine block from the Simulink library, and here we have taken the armature voltage source. Okay, and this one is field winding. This is a DC voltage source. Okay, so parameters you need to give the DC machine. Here preset model should be 10 HP 240 1750 RPM. Okay, so select fourth one, click on OK here. So then this is armature voltage, so double click, give the value as 240 here, click on OK. Again copy this block and flip in the anti-clockwise, okay, or counterclockwise. So after that double click here, so this value should be 300, field winding voltage should be 300 volts, click on OK. So place it here, connect positive to the field winding, negative to the negative of the field winding. Okay, so like this you need to connect the blocks. So now we have given the armature current and the field current voltage, sorry. Okay, so after this you need to take one more block called step. Okay, so you need to take step, go to the signal routings. Here you can find the step wave sources. Go to the sources. So here you will find the step wave. Okay, take this one, connect it with the TL. So TL here. Okay, so after connecting to TL, double click here on the step block. Okay, so here the step time must be 1, initial value must be 0, and final value must be 8. Okay, change the value as 8, final value should be 8. Okay, so after this click on OK, then go to the sinks, take the display module, click on add block. Okay, so here you can connect it to the measurement here. Okay, so you will get multiple values, so that one I will show while running, while executing. Okay, so after that if you need any graph visual, means you can just add the scope block and connect it parallel to the display like this. Okay, so after this you need to take the ground block. Okay, so search for ground here and select the correct one. If you take wrong one, means it will not execute. Okay, so search for ground, scroll down here, inside Simscape. Okay, Simscape there will be a block called ground, this one. There are similar blocks, but you don't take these one. Okay, this is electrical reference, this one is grounded neutral, this one is ground, actual block is this one. Okay, add this block to the model and you need to connect it to the DC field voltage and the armature voltage. Okay, connect it to the armature voltage and the field voltage, this one here, connect it to the negative here, and again one more, connect it to the field windings like this. Okay, we have connected two grounds. Okay, so after this go to the Simulink library, search for power GUI block. Okay, search for power GUI block, you will get the power GUI block, add block, so place it here. You can place it anywhere. Okay, yes. So now this is all the connections you need to do it for the DC motor. Okay, without these blocks it will not run. Okay, no? So one more thing, here on the measurement it will show all the values. Okay, so if you need certain or particular value, means you can sort out it using bus selector. Okay, so that one I will show after one execution. Okay, yes. So now this is a circuit. Okay, now so if you have any doubts in the connections or any blocks, means you can just put a message, or you can just unmute and ask. Okay. Yes, so this is the simple interface of a DC machine. Okay, so now we will check all the values, output values. So output values means like speed, current, voltage, torque, like that values. Okay, in the single display, because this M terminal will give all the values from the motor. Okay, so let us execute this program. Click on the run button on the top side. The module is compiling. Wait for some time. Yes, so here we got multiple values. So I will just increase the display size. Yes, we got the 4 values here. Okay, so what are the 4 values that we will find out using the bus selector. Okay, so here you can see the values 105, 3.5, 1.25, 7.99. Okay, so when you open the scope means you will find all the values which are integrated in a single graph. Okay, so after opening the graph, just click on the auto scale here. Okay, you will find the waveforms. So to show this waveform different in a different graph means just, so here we need to select the number of inputs. Okay, so here you can select multiple inputs. Okay, either you can make it as 3. Okay, so I will make it as 4. Okay, so we got the 4 values here. Okay, I will make the input as 4. Okay, so we got 4 graphs here. Just I will close this one. Okay, so now we need to connect the bus selector. So here we can't know about the values. Okay, if you double click on the DC motor means, so here it will show measurement output like that, parameters. So it will not show what are the values out in the measurement block. Okay, so that's why we need to take the bus selector here. Go to the Simulink library. Okay, go to the signal routings. Okay, signal routings. Here we need to take the bus selector here. Take the bus selector, place it here. Okay, so then we need to connect this measurement block to the bus selector, not to display. Okay, just we will delete this connection here, also this one. So take the bus selector. So you should take bus selector, not creator. So it is a bus selector. Connect the M to this bus selector here. Okay, so now we have connected the M to the bus selector. Now you need to double click on the bus selector. Double click here. Double click on the bus selector. Yes, so here we here you can see there is a values. The one is speed, armature current, field current, and next one is torque. Okay, these are the 4 values. You can see it in the measurement block. Okay, so after this you need to delete these 2. So these are the default signals. Just select this one, and here you click on remove. Okay, so remove both the signals. So after this, select the values which you have required. Okay, so we commonly we will use the speed value. Okay, select the speed and click on select button here. It will list out in the other side. Okay, so you can select all the signals, or else you can only take particular signals. Okay, and you can obtain the different outputs here. So I will take speed and armature current. I will take the armature current and speed, the 2 values. Okay, I will take only 2 values. After that you can take all 4 values and check it. Okay, so first initially we will take it speed and armature current here. So after this we got the speed here, so you can connect it to the display here. Okay, so this is a speed. Okay, again I will copy one more display. Okay, one more display and connect it to the armature current. This is the armature current. Okay, so like that you can connect the scope block also here. I will connect first pin of the scope to the speed value, second pin to the armature current. Yes. So now I will try to run the simulation. So let us see the output. We got the speed around 105, okay, rpm, and the armature current around 3.5 amps. Okay, you can reduce this size like this. This one also you can make it smaller. Yes. Okay, so this is all about the speed and current. So after that you can check the signals here, output signals. So just open the graph and click on the auto scale here. It will obtain the values. So first two graphs we have connected the signals. Second two pins we have not connected. Okay, it is not connected. That's why the waveform is 0. So here it is showing 0 0. So but in the first and second it is showing the exact values. So what are the values? So here you can see the values in the y-axis. Yes, so for the armature current, so here there is a naming armature current. So armature current is around 3.5 amps like this, and the speed is around 105 rpm. So you can just zoom it, you can select some amount of area. Yes, so here you can check the waveform. This is the current, this is the speed. Okay, so after this you can take two more values. Just double click on the bus selector, connect field current, select the field current and click on select here. So after field current you can take the torque also. Select this and click on the select button, then click on OK. Yes, so after this we got 4 outputs from the bus selector. Okay, total 4 outputs from the bus selector. Then we will connect this to scope. This is the field current. Then the last one is torque, so we will connect it to the scope. Yes, so we have connected total 4 values from the motor. We are reading 4 values from the motor. So let us run this simulation and check the output. Yes, the program is executed. Just double click on the scope. Yes. So now click on the auto scale here. Yes, so this is about the different values. Okay, yes, so we got the speed that is 105, not changed. Okay, so then armature current, that is 3.5. Then we have field current. So field current near to 1.25. Yes, 1.25. Then the electrical torque is around 7.9. Okay, near to 8. Okay, and we got the field current here. These are the different outputs you can obtain from the DC motor. Okay, and this is a DC signals, not AC. This is DC. So where here it is a pure DC, but here there is some noise. We can clear that noise and obtain the signal like this, similar, but you need to use extra modules, extra blocks. Okay, yes, so here there is automatically it taken names. Okay, so speed, armature current, field current and electrical torque. So it is a very simple interface. Okay, so after this for the same motor you can implement direction control, speed control, open loop speed control, closed loop speed control. All these features you can add on to the interface. Okay, yes, so this is all about, this is about the DC machine interface. So if you have any doubts related to this, means you can just put a message, or else you can just unmute and ask the questions. Yes, we have completed the simulation. Just select the area where we have built the simulation. Okay, so after selecting, just at the bottom side there will be like a box, create area. Click on that, so an area will be created, this one. Okay, yes. So here you can see the values. So one is speed, one is armature current. You can also use four displays for four values also. Okay, so to simple for the simple operation we have used only two displays. Done. Yes, so this is all about the DC motor interface. So I think all of you have executed the same circuit. So once more I will tell all the parameters which you need to give in the circuit. First one is you need to take the DC machine, double click, give the preset model. So select the preset model as fourth one, that is 10 HP 240 1750 RPM, field 300 watts. This voltage you need to give it in the input side. So here, so across the armature you need to give the voltage 240. Across the field you need to give the voltage of 300. Okay, so here we have selected the particular model. Okay, so after this you need to click on OK. Click on OK. So then click on the step model. So here you need to change the final value should be 8. Okay, so after this click on OK. So this one, voltage across the armature, it should be 240, and voltage across the field winding, that should be 300 volts. So these are the parameters you need to give it in the simulation. Okay, so this is all about the DC motor interface. After this, click on save button, save it in the desktop folder. So this should this one you need to do it in every class. Okay, after every module completion you need to do this step. Okay, so go to the desktop. So inside the desktop we have created MATLAB Simulink files. Okay, and here give the name DC motor, enter. Okay, complete it fast. So after this interface we will start with the BLDC motor.